Here goes all about triangle. In this digital math notebook by Miss Nong, I'm showing you all topics I could think of related to triangles. We start off with the content page, 2 green arrows. The first one is on any kind of triangle. We started off with classifying the triangle, and remember this part, there are different triangles in here, including right triangle. In the second part, the later part, we're going to focus on the right triangles, and we start off with Pythagorean Theorem, the Pythagorean triples, special right triangles, and finally we are going to finish with trigonometry. Which strategy should I use first? Which one do I use to find the side length? You can use Pythagorean Theorem, you can use the special right triangle, 30, 60, 90 and 45, 45, 90 formulas. You may also use trigonometry. It's going to go in this order, 1, 2, and then 3 finally. And to find the angle, which one do I use first? First, you're going to use a triangle angle sum. And you're going to see if the triangle is an isosceles or equilateral, and use those to apply and find the angle. So you can see trigonometry is where we save it for the last part when we are unable to solve using one of the other two methods. In this lesson today, you are going to learn how to use the Pythagorean Theorem. Let's go ahead and start off with that one. And also related to Pythagorean Theorem, we also have the Pythagorean triples. Triangle inequality, we went over this theorem previously. And this is where you can classify if the triangle can exist. Here is our focus, Pythagorean theorems. I want you to know that for Pythagorean theorems, we can only use in right triangles. So not for obtuse triangle, not for acute angle or scalene, only right triangles. For the right triangles, the opposite to the right angles, or right across from the right angle, is the longest side. And we call this longest side the hypotenuse. Usually it's labeled as length C. And then the leg and the other leg will be called leg A and leg B. And it doesn't matter which leg I'm going to label A or B. Here are the practice problem that we are going to show you how to solve using the converse of Pythagorean theorem as well as the Pythagorean theorems. And then finally, we're going to end with the Pythagorean triples. Here are the related flashcards, notes, and Pythagorean theorems. Remember, it's only used for a right triangle. And you can use the Pythagorean theorems in the right triangle to find a missing side, to check if the triangle is an acute triangle, an obtuse triangle, or a right triangle. We have the Pythagorean, which is a squared plus b squared equals c squared. Let's go ahead and find this missing side length. You can see the left hand side here with the red question mark. We don't have that side length, and we know that this is a right triangle. Then we can use the Pythagorean theorem with the hypotenuse being 10 and one side being 6. Remember, hypotenuse is always the longest side that we have, and it's always across from the right angle. Call it X for the missing numbers. B is one of the leg, and the B letter here, I could switch it for the letter A, is one of the leg. It doesn't matter which leg, A or B. And the C is the one that we must put it in correctly. To substitute using the number we have for ABC, we have x squared plus 6 squared equal 10 squared. And now we're going to simplify the exponent, the square on the numbers. So x squared stay the same. 6 squared become 36 because that's 6 times 6. 10 squared become 100. And then I subtract 36 from both sides to isolate the x and solve for x. I get x squared equals 64. And now I'm almost done, but I'm not done yet. So be careful here. X squared is not x. We're looking for the x. So the next step is we're going to do the opposite of the square. Remember the exponent square there. The opposite of that to cancel it out, it's going to be the square root. And that's a green square root on both sides. We do the same on both sides. And when I take the square root, I'm just looking for something that multiplies itself. So 8 times 8 equals 64, and I can go ahead and take it out of the square root. X equals 8 is the answer that we have. And it is a right triangle. We can use the formula to find the missing side. On the right hand side here, I'm leaving you the reminder of the Pythagorean theorems. On the left hand side, we are showing you how to solve problem using the converse of the Pythagorean theorem. So these are called self-check worksheets. You might see the line that is on the bottom right here, where some of the students will skip this part because they think that they have all the work on the top, and just skipping that minor part will not be anything. But be careful, because this minor part right down here, the self-check part, is the part that will actually make sure that you are on the right track. When you decode and the message makes sense and everything spelled correctly, you know that you're on the right track. But if this message spelled incorrectly, then all of the problem or any problem that you have misspelled, that's the one that is wrong, and you know then to be able to correct yourself or find the correct way to answer the questions. So don't skip the small part or the bottom part here, the self-check part. The Pythagorean theorems can be used to determine whether a triangle is right, acute, or obtuse. Think of this long side as C and the two shorter sides as A and B. If the theorem is going to be C squared equal A squared plus B squared, then you have a right triangle. And the example is right here, where we have the side length of 3, 4, and 5. We applied it into the theorems here, and we get 25 on the left side equal to 9 plus 16, which is 25 on the right side. So then this is a right triangle. And if the longest side square is less than the sum of the other two sides, a squared plus b squared, like in this example we have 4, 5, 6, we applied it and we get 36, which is less than 16 plus 25 on the right hand side here, then you're going to have an acute triangle. And then we get obtuse triangle. The longest side square is greater than the sum of the other two sides, a squared plus b squared. So right here you get an obtuse when you get 16, and on this side 9 plus 4 is only 13, so 16 is greater, and that's why we get an obtuse triangle. Let's go ahead and work out some of these. It said determine whether the following lengths create a right, acute, or obtuse triangle or no triangle. Shade in the matching column letters and copy them onto the blanks to review the name of the US president who discovered a proof of the Pythagorean theorem. Then 6, 8, and 10. So the first thing I want to do is I want to check if it can be a triangle or no triangle. This is where you're going to have to recall prior knowledge. This is from the triangle inequality theorems. The sum of any two sides has to be greater than the third side. If you check on the first one here, we can have a triangle exists with these 4, 6, and 8 lengths because 4 and 6 add, and it can be longer than the 8, the third side. And that is with any combination. Again, 4a is going to be bigger than 6, and then 8 and 6 of course is going to be longer than the 4. So any two side length has to be longer than the third side, and we can have a triangle. When the two sides are going to be equal to the third side, like 5 and 3 right here, when we add, we cannot raise it up. We cannot make a triangle. So it cannot be a triangle, and that's where we would shade this choice, no triangle. And again, 3 and 4, we get 7. So 7, we cannot close the top. There's no triangle possible on this one. So again, you would mark no triangle when that happens. 6, 8, and 10, you can do a quick check. 6 and 8, yes, longer than 10. After I check, I know this can be a triangle and I can proceed. So write it out. This is going to be the part where we're going to show work. I'm going to go ahead and start off with the longest side, which is 10, and 10 would be my C. 6 and 8 can be put in for A and B, and it doesn't matter which one. 6 can be first, or number 8 can be first, plus 6 squared. I'm going to go ahead and simplify. 10 times 10 is 100, equal 6 times 6, 36, plus 8 times 8 be 64. Try to line up your equal sign. One more thing that I forgot to put in here, when you're writing this word, you want to go ahead and put a question mark on top of the equal sign, because we're not sure if this is equal or greater or less. So we're putting the question mark on top of each of these equal signs until we know for sure. Like this one, we know that this is going to be 100. So that's the letter J. Go ahead and put it in right here. Don't wait until the end, because this is the process where we can double check our work to make sure that we're on the right track. If we circle the wrong letter and you wait until the end to put all the letter in, then you might find out that, oh, I did it all wrong and wasted all of the time doing the wrong thing. Go ahead and start with number 2. Do a quick check for triangle or no triangle. The 2 shortest side, I added 2 to 1, I get 3. It is going to be this scenario when you get 2 sides equal to the third side. You cannot raise it up and make a triangle. So no triangle is possible on this one, and I don't have to waste all of this work. The converse of Pythagorean theorem, when I already know the answers, I can go ahead and put it.
No triangle possible. So A is the letter that I'm going to go ahead and put down here.
The next one, we are going to check these 3 numbers, 5, 5, 5. They are all equal numbers. Find the picture for this number 3 right here and mark the side, the same number of tick mark. Equilateral also mean that we also have equal angular, which means we take 180, we divide by 3, and we would get 60 degrees. And when we have a 60-degree angle, we don't have a right angle. We are going to have an acute angle. That is most likely going to be acute for the answer here. Again, we don't have obtuse because 60 degree is less than 90. We don't have any bigger than 90 degree. So my answer here is going to be the letter M. And remember to fill in the letter as soon as you're done with the problem so that you can make sure that you're on the right track. Don't wait until the very end where you might find out that you misspelled something or you did something wrong all the way. Go ahead and finish number 4 and the rest of these on this page. Have fun.